Okay, in this video I will explain about the Rolle's theorem and how to use the Rolle theorem to prove the existence of critical points or extreme points on some interval. Okay, um, the Rolle theorem says if we have a differentiable function, okay, differentiable function on some interval a and b, and the function values at 2 and points are equal, then there exists at least one c in between a and b such that the derivative equal to 0. Alright, let me analyze this theorem in different ways. Okay, so what does mean f is differentiable on this interval? That means on this interval, at any point on this interval, the graph of function has tangent line. Differentiable means it has tangent line, right? Alright. Secondly, f of a equal to f of b. What does it mean? That means f of a and f of b are on the same level, right? And then when you connect this point, you have a horizontal tangent, a horizontal line. Horizontal line means the slope of that straight line is just 0, because that straight line is horizontal, meaning the slope is 0. Alright, next. What does mean f derivative equal to 0? F derivative equal to 0 means, first, the slope of the tangent line at C is 0. Means the tangent line at C is horizontal. Okay? Or this means in between A and B, there exists at least one action point. Or there exists at least one action mark. Maybe. Because we're looking for action mark at critical points, right? And what are critical points? Critical points are points where the first derivative equal to 0 or the first derivative does not exist. But our function is differentiable. That means the derivative exists everywhere in here, right? So we have only one case where the first derivative equal to 0. So the Rolle theorem says about the existence of extreme points, or means maybe about the existence of extrema on that interval. So that is very important. Okay, how to understand the Rolle theorem? So as we see, FAE equal to FB means the straight line passing through these 2 points, right, is horizontal, means the slope is equal to 0. And the graph has tangent line everywhere in here. So if you move from this point, right, to this point along the curve, so each time you have some tangent line here, you have some tangent line here. Make sense? And the Rolle theorem say, and this graphically, you see, there exists at least one tangent line where this tangent line is parallel to this guy. But this guy is horizontal, means the slope is equal to 0. Means that guy is also horizontal, right? And the slope is equal to 0. But what is the slope? The slope is the derivative at that point. So that's why we have this condition. Okay, so that is about the Rolle theorem. So let's say one more time. The Rolle theorem says about the existence of extreme point on some interval when we have FA equal to FB. And the Rolle theorem says about maybe about the existence of extrema. And the Rolle theorem says about horizontal tangent line at some point. If we have this condition, right? So let's consider this example. We have some function in here, and we need to show that f derivative equal to 0 at some point, right, in between 2 x-intercepts. I will explain later after this solution, but let's find all x-intercepts of this function first. So I will write here, okay, find x-intercept, right? So x-intercept means we have to set the function equal to 0. The function is x square root of x plus 9 equal to 0. From here you get x equal to 0 or x plus 9 equal to 0, right? So x equal to 0 or x equal to negative 9. The function has 2 x-intercepts. And now they ask us to show that the derivative equal to 0, the equation derivative equal to 0, has solution in between -9 and 0. So our interval is -9 and 0. That is our interval. I mean, it's some kind of play roles of A and B, right? A and B. So we need to show that there is at least one action point in between -9 and 0. So from here, once we follow x-intercepts, we move to the second step. So f of -9 equal to f of 0 equal to 0, because -9 and 0 are x-intercepts, right, of this function. And this function is differentiable. That is the first thing. The function fx is differentiable on -9, 0. Right? Why? Because x is differentiable function, right? Everywhere. S squared of x plus 9 is also differentiable everywhere when x plus 9 is greater than 0. So the product is differentiable on -9 and 0. So by the Rolle theorem, from here, you see this function satisfies conditions of the Rolle theorem, right? So I say by the Rolle theorem, there's x 1c, there's x c, right? A c in -9, 0, such that f derivative of c equal to 0. So we finish this problem. We just proved the existence of critical, of action points in -9 and 0. And if you see this, right, look at this solution. Basically, we don't need to differentiate the function. You see, they asked us to prove the existence of solution of this, but we didn't differentiate the function. We didn't find derivative, and we still can prove the existence of c, right, of this equation. So that is the power of the Rolle theorem. Just without differentiation, we can prove that the function has at least one action point. Okay, and now let's find that action point. Once we convinced that, actually action point is x, so let's find that. Now I can take derivative. Let's take derivative of this function. F derivative equal to, I use the product rule. Here I get 1, I get square root of x plus 9, and here I have x, and the derivative of square root of x plus 9 is nothing 1 over 2 times x plus 9, right? 1 x plus 9. So I have to set it equal to 0. I mean, that is usual way when we look for critical points. So I set this equal to 0. From here I get square root of x plus 9 equal to -x over 2 times x plus 9. And now I use cross multiplication. I have 2 times square root of x plus 9 square equal to -x. But this is nothing but x plus 9 equal to -x. I'll have 2x plus 18 equal to -x. So I bring x into this side, I have 3x equal to -18, right? So x is equal to -6. So that's how we can use the Rolle theorem, you see. So basically, in mathematics, we have two main problems. First, we have to talk about the existence of something. Once that object exists, we go to the second step, find that. You see? So the Rolle theorem says about the existence. Okay?